are some of the very interesting things that we saw. April 13, 2020, there were 9 cases, right? Say, for example, 9 cases in one particular sub-post office, Anand district. And right, and by April 30th, there are 123 cases, right? This is real group. And the district was declared red by government on April 30th, right? On April 13th, there are only 9 cases. But at that point, our fellow, the Itihas basically told that this is a hotspot, go and address this. Similarly, Chitari, Bazaar and King Kulot. So some districts in some sub-post office in Anand district, Gujarat. So we had 2 hidden hotspots on April 13th in Anand district with a very, very, very high, heavy score there. Like so many people have been exposed. But then at that day, there are only 9 cases. But within the next 15 days, you see that it has gone to 123 cases. So this was a case study, right? So these are the things that gave us confidence that, okay, we are, this is a very worthwhile effort. Next. So this is in Madhya Pradesh. If you take, there are only 1 case on April 13th, but on that day, the software platform, the dashboard told that this Dhar district is really a Dhar. Okay, it's going towards a real problem. So there are only 1 case that day, but there was 1 hotspot there, and by May 2nd, that 1 case became 82 cases. So this is another prediction stuff. Next, then this is Tamil Nadu again. On April 13th, there were 17 cases, but there were 7 hidden hotspots in Tanjavur district. And then by May 2nd, from 7, just 2 cases, Tanjavur became 66 cases by May 2nd, right? So this was something, but very, very important that time. So essentially, these case studies basically tell us that there was a, very much in advance that these areas are going to blow up and some actions could be taken. So these were some of the very, very initial results that showed that the system is indeed working and is making some sense. Okay, next. So this is also another case study of Kanchipuram districts. We had only 3 cases on, 19 cases on April 13th, while by May 2nd, it became 97 cases. And there were 21 hidden spots on April 13th in Kanchipuram district. Right. Next. So we had this grid-based system. We made grids of 100 meter cross 100 meter across India, the large grid-based system. Every post office lat long was mapped onto a box in this grid. So given a query point, a lat long, which is a box B, to a query point, we find out to which box B belongs to, and we search for the closest box to B, which is mapping a pin code. So at every sub-post office, we provide the trace and caller list. So this is how we mapped. This is a very simple mapping system. And we mapped basically the given lat long, we'll find which box it belongs to. And from that box, we find the closest post office, sub-post office, and we assign that particular case to that sub-post office. And we also give the caller list and trace list to that sub-post office so that some collective action can be taken. So a grid-based, simple grid-based system was used here for this. Next. So the next part was to derive insights. So statistics actually played a very crucial role here. So based on self-assessment and trace details, the statisticians actually performed. Bharadwaj was from IIC was also involved in this. A syndromic mapping, which predicts the presence and spread of the disease in a given area which can be mapped onto the sub-post office areas. And based on this syndromic mapping, we classify each area as very high risk, moderate risk, and low risk, and pointed areas within the sub-post office where the exposure is maximum. So that also we did. So only aggregate information of each towers was taken and no personal mobile information was taken here. So this enabled a process. So we also see there was these basically the sub-post office, since there was latitude and longitude, we were able to even basically do certain geometric structures like Voronoi diagram, as you see on the right-hand side here, which actually basically gave the area, possible area of exposure based on the data that we had got. So there was some computational geometry also used here. And based on this, this enabled what we call as a catch early and contain early protocol, which was very rigorously implemented by Ahmedabad Municipal Corporation. Further, this was adapted by multiple districts of Gujarat and many districts of Punjab, Goa, all people were using at that point of time. Okay, next. So these were some of the good case studies. So Arogyasetu was to use on May 27th. Ahmedabad decided to use Arogyasetu to pinpoint hotspots in Ahmedabad. Next. So this is what happened by July 17th. The cases had come down from 330 to 180. From June 17 to July 17. It has come down from 330 to 187, while the deaths also dipped from 22 to 5. So this was the biggest thing. And there were a lot of projections, statistical projections, while Ahmedabad for all, and at least for the 5 cities, which were growing, 6 cities that were growing very badly that time. It was Chennai, Delhi, Mumbai, Pune, Bangalore, and Ahmedabad. And as you see, Ahmedabad flattened it very quickly. A very, very rigorous follow-up and stuff like that. And you see that the green curve, which is Ahmedabad, how it has flattened. Okay, so this was one of the, I may say, a success story of COVID containment based on this data that we had got. Next. The 2 real reasons why Ahmedabad was successful is data is something like a placard, which tells you a place X is 100 kilometers from here. The placard will not run with you, right? You have to travel that 100 kilometers. So there was a dedicated team at Ahmedabad Municipal Corporation which worked round the clock. And very importantly, people did submit the self-assessment and carried mobile phone keeping Bluetooth on. So the end user acceptance was there. They believe that this system is important for the nation. They believe that this can be helpful. So the citizen believed in this software, and that is why it worked at that point of time. Next. So the human aspects is very important. You should trust that the app is serving you and the country. And very importantly, it can be deleted at any time if you feel that it is intrusive or whatever. And first, the trust. Trust is very important, right? Trust is not a mathematical property, in my opinion, right? Trust is, if it is a mathematical property, you can't even define it. Suppose I want to say trust is equivalent to some definition. Any equivalent relationship should be reflexive, symmetric, and transitive, right? So trust is not reflexive. Sometimes you don't trust yourself. Trust is not symmetric. A trust B, B may not trust A. A trust is not transitive. A trust B, B trust C, A need not trust C. And it is temporal. So morning I trust, evening I don't trust. Context dependent. I trust on some on something X, but I don't trust on something Y. So it is highly context dependent. So trust is transcends all mathematical properties. So that is very important here. And that, how do we build it? That's also important. And any negative report which did happen at those point of time actually was to hamper this trust, and that's how the software could not spread to whatever we conceived as at least 50 crore users. We are at 19 crore, even though that was a large amount of population which was used. And concerns regarding privacy and data security, there was explanation of working privacy and data retention process, all were made public, and that is also very important. Public could see that. And very importantly, the government also opened up the code base for everyone to verify what is happening. The entire source code was also made verified. So all these things came up, but the whole the point was that at the initial stages there were certain reviews and certain public statements made which was doubting this and created a doubt among public, and that did hamper the very quick propagation of the software. But nevertheless, this has, at least we had one case study to show, a very big case study to show that this was very useful. Next. So just to touch, I'll just wind up in another couple of minutes. So I'm just shooting there. So development involved application development. So there was a client, just a mobile. Very important, there was the compatibility, the backend, cloud, and it has scalability there. And then APIs for analytics and performance testing. This was done by IIT Madras using an open source tool called Apido, this open source tool, where we were able to test the real, number of concurrent users. And this is complete open source. When you go for commercial performance testing tool, we would have needed a couple of million USDs. Again, security testing, advanced penetration tests for protecting data was done. The entire data analytics of Ithihas was done using this open source stack from IIT Madras, which is available in datalibre.org.in. Currently, we have processed more than 600 crore records in that. Right? So it's a really very big data processing system that we have built up there. Next. So all the pre-production performance assurance was then. So there was stress testing, there was SLA-based testing, capacity planning testing, reliability testing, stress testing, performance tuning, and regression tests. All this were done. Again, the point was we had only 21 days, and this whole testing happened within 3 days, and back and forth, multiple tests, and to stabilize the software. So this essentially proves that as a country, we have really, really good engineers who can build large-scale, correct, working, sensible software in a very short period of time. This really talks about the agility of our software development. I believe that my full trust on the country increased multi-folds on the successful deployment of the software. Next. Then a lot of things were done in terms of testing. So we did application layer assessments and also OS and architecture assessments. We did all these things: authentication, access control, session management, data transmission security, encryption and obfuscation, input and error handling, data protection, and many things more. On the OS side, web services and infrastructure was assessed. Permission models were assessed, residual data analysis was done, application licensing, now multiple things were basically done here. So all these were done as a part of our security testing. Right? Next. So this was the complete stuff that we could achieve at that point of time. Next. And everything was open source. So this is to sum up. Yes, this is Arogyasetu, what we have achieved. I don't know how much it had been useful, but it was essentially helpful in testing at that point of time. Now I open up to questions. Thank you very
much. Thank you, Professor Kamakoti. We'll now have questions from the audience. Please type your questions on the chat box, and then I will read it out for Professor Kama to answer. While we wait for your questions, maybe I'll begin with the question. I hope you're able to hear me.
Yes.
Okay. So the first question is, there is a big design question related to who should know what, so that trust is an important factor that's taken into account from the beginning at the design stage itself. So did Arogyasetu team, did you have any social scientists in your team and also people that could understand these aspects, and what kind of considerations did they suggest if they were there in the team?
So the need to know principle was followed from day one, and then we did have lawyers and social scientists, basically also doctors who understand the social aspects of treatment, right? So all these three people were fully involved. And first we started with the policy, right? What is the policy that we are going to announce? While there were this contact tracing, Bluetooth characterizations that were going on very fast, but we also started working parallelly on the what is the policy statement, the sunset policy, where should the data rest, what's the encryption mechanism that need to be proved, and then very importantly, when should the data be taken up, and what should be the message that needs to be delivered, and what should I tell when somebody submits a self-assessment? So all these things were really taken up, and sometimes we also ask things like profession, right? So why do we need profession? This was a very big question asked in one of the things, right? We needed profession because we wanted to give, say, suppose they are a frontline worker, we really wanted to give them more secure protection in this. So that is also something that we took up, because if it is a frontline, if the person was a frontline worker, then there might be other people who did not have Arogyasetu there. And so we would like to call that person and say where and all you visited, and probably we'll go and check those places. So many things were decided at that point. And every stage, when a data is at rest or in motion, should it rest here? And if it rests, what it means? If it is moving here, why should it move? These debates were completely answered.
Thank you. We have a question from Chandan, I think. So I'll just read out the question. Great job done and implemented. Now, balance relation on trust. My question is, what will the data collected during the pandemic? How will, let me rephrase this. How will the data that we have collected during the pandemic be used later? Is it just going to be for storage and utilization then, or will it eventually be given to the public? So I have interpreted and posed the question. Over to you.
Sure. So the point is that there are certain hotspot detection, like this particular area has, this was the COVID score. What was the COVID score? I didn't explain the COVID score. I did not go into much details because of lack of time. How many hours a particular COVID patient actually spent here, right? That also we can get from the see what we call as the positive, for all positive patients who have tested positive. The mobile tower association data is that which tower they have been associated with, right? So from that we could also find out at every sub-post office how many self-assessment has come here, how many patients have spent time there. From that we could get something called a COVID score. This is an aggregate score. There's nothing personal, or we don't know who visited or anything. It's just an aggregate score. That so many COVID patients spend so much time there.
Mm-hmm.
That information is still there. So at least till January we had been running this. After that we stopped because cases have come down. So that the data, the government can decide and give it in public. So just to understand how the virus has spread over days. So that is the only data that's the only data that is also going to make sense.
Okay. Next question is actually from Joy. He has two questions. So the first is, can you provide an idea of the person months of effort that was needed to design and implement Arogyasetu? You did it in 21 days, but how many people were involved?
Yeah.
And
so there were actually, it's actually there in the Wikipedia page, but I'm sure it was 28 people. So it was around 600 to 700 person months that was needed to develop this. And of course, there were other people, non-software people also in this, who were basically reviewing this. So I'm including all those people. So the team was around 28 people spread over 21 days. And of course, for release, okay, so the first release. Now, so that is the whole stuff. Then what is the next question?
Next question is, were there any special considerations to ensure security of the Arogyasetu application itself in order to make it hack proof. On a phone, for example, people could have maybe hacked it and made
So
it operational.
on the phone, of course, we had a penetration testing which was done on the mobile phone with the latest version of Android or even slightly lesser versions of Android, and also on the and also iOS. That was actually done, and then on the cloud also multiple security tests was done. Every time a release was made, before that a security test was done. So basically to hack. And then we also opened up a competition, putting all these things and said that if you hack, and we will give you a prize. Nobody hacked. Okay, so public competition was put.
Thank you. Next question is from Professor Vijay Chandru, who's in the class here. Can you describe the role of chatbots in the deployment?
So I think very little later there was a chatbot which was given, but I don't know whether it was ML enabled. Sorry, it was AI enabled, but it was basically answering the questions. The chatbot essentially was to tell where is the nearest hospital, where is the nearest COVID care center, and later when it came to vaccination, where's the nearest vaccination center. So these are the main queries that are put as a part of the chat box. And I also I didn't check the latest version, but I think it was also made a multilingual one. Right? So these were some of the things.
Thank you. Next question is from Shobit Prakash. So being an ML student, I'm interested in the ML algorithms that were used in the hidden hotspot prediction. Can you tell us what kind of data was used for this prediction?
Okay, so the data was how many people submitted self-assessment there and how many COVID positive patients were there at a particular post office. This was the only data. And the only thing that we learned was that how do we fix the threshold? So based on that, we got something called a COVID score. And we also wanted to map the COVID score onto the spread. So initially we said, okay, something like, COVID score of 100 means it is going to blow up. So how do you classify this? So this was basically a classification problem, multi-classification problem. So I have to classify it as pink, amber, dark blue, and light blue, right? So how do we fix? So we fixed pink as 250. Beyond 250 is going to, and this has some 132 or something like that. So how do we fix these threshold? Basically went through this ML, which was actually a training which we did. Initially, we started with some other value, then we moved it and finally freezed at 250, wherein we said that we got several data people and then simply used a simple ML model. I don't remember the model that we put there, but simple ML model, which basically gave us these values of, predicted the values of these thresholds that we need to assign. And that was what was done. Other than that, we used current score to actually predict the number of active cases, right? But then the actual number of active cases that could come there, and that was actually changing. So when we do for one thing, it was very good for the first wave, but the second wave we had to redo it completely. And again, the third wave was something by the time it predicted, the wave ended. So this is also something very, very important. Yeah, each wave had its unique characteristics, and the ML failed to spawn across waves in this particular direction. So these were the two ML interventions that we have.
Next question is actually from our class, Tarun Khandelwal, who has posted it on the chat as well. He's also here in the class. I'm guessing that there would have been some difference in the adoption of the Arogyasetu app across the different states in the country. Do you have any insights on the adoption rates? Which state had the maximum, which had the minimum, maybe district-wise? Did we observe any link between app adoption and COVID-19 spread?
Yeah, so app adoption, there was a state where very good app adoption. That was Gujarat, right? So Gujarat, and the moment the app adoption was strong, because they also went on a campaign saying, no, for the health workers, they did offer an incentive, some small incentive, saying, go and get at least 50 people, install Arogyasetu app. Because that time the cases at Ahmedabad were just growing, just exploding. And we didn't know what to do. So this was very useful at that point. And so when the app adoption was good, people were able to precisely come out with containment zones and stuff like that. So they were using it very nicely. But there are other places, for whatever reason, the app adoption was very, very bad, right? So very less, right? I don't want to mention states, but there were, and then there was real blow up of, there are no insights that one can provide from this thing. So this insight was missing.
So here I have a follow-on question. Could we have published this adoption percentage, for example, to make maybe individuals from various states see what the other states are doing, and perhaps
this was actually, so this was actually, so I personally had done multiple demos to multiple district collectors across the country. So personally, I had handled around more than 25 meetings with district collectors of different places organized by the government. So this information was basically given. But again, see, we are a democratic setup, so we basically can't force anybody to install an app or not. Okay, so that's very important. So adoption basically, one Ahmedabad, for example, Surat, for another example, all this, some of these states, when they did this adoption from Punjab, actually, Punjab also did quite a good adoption there. Certainly, there was some insights that we can give, and they were able to. They gave a return feedback saying that they were able to control.
Any correlation between the adoption and the cases going up?
As I told you, in terms of Ahmedabad and Punjab and this, there were really this app has helped, and they have brought down the cases. They could show the bringing down of the cases here.
Yeah. So is in that context? Is there something, because Arogyasetu was sort of more like a service app than a research app, perhaps to publish the insights from this data, we might need to go back to some ethics committee and get some approvals. Yes. But do you think there is scope for doing this, showing that the correlation of adoption as well as adoption with the reduction in the cases is actually positive, and therefore we might want to demonstrate this by conducting some research and then maybe increase adoption in future. So any thoughts on this?
Yeah, so again, for the data to come out, there's an ethics committee that needs to clear it. And I hope that, when after this, again, we see some other variant and some increase in the number of cases that some of the states that I saw today morning news. Hopefully, there's nothing more. It's really frustrating, right? So, but once this is all ended, I think we need to do a very good, see if the present sits in judgment over the past, it has no future. If the present fails to learn lessons from the past, again, it doesn't have future. They're both, I believe. So we should start learning the lessons from past. I think whatever data we have stored, I think at some point of time, this can be released, and then some very good insights will come out of it, right? And it will be a good place. So we are also maintaining, myself and Rajesh, we are helping in maintaining the incovid19.org. It's also very, very important for us, right? And so I think these data will be very, very useful. At least hope no more pandemic like this, but in case of an unfortunate event of a pandemic, I think this data will be extremely useful.
So for a post hoc analysis, this is a question from me. For a post hoc analysis, it would actually be great if we could combine this data with the NCDC data, with the time series data of test outcomes from ICMR. Of course, there are perhaps some sensitivities involved at this stage in the sharing and in the putting together of this data. But do you think that in the future, maybe after the pandemic wanes down, that there might be a study or an integrated study of all of these things? What do you think would be the usefulness of such a study? Can you speculate a little bit?
Yeah, there will be a study, there should be a study, and that will be extremely useful for us. And there is no doubt about it, right? So I think once the pandemic ends and things are stabilized, I think there will be a concerted effort to learn lessons from this. And I think many of us will be involved for sure. And this study will certainly happen, right? And then, and also things like, even from a medical point of view, that's the technology. So see, IIC is coming out with our hospital, IIT Madras is also, trying to do something. So this medical sciences and technology is an outcome. And these departments, there'll be a lot of data analytics involved. And I'm sure that these departments are going to come out with these studies from this data. This data cannot go as waste. That's my.
Perhaps we might have to do it right away. Maybe the next variant is at our doorstep, and we might have to do it right away. There's another question from our class here. Does Arogyasetu take into account the immunity of individuals due to vaccinations or perhaps due to past infections while making your insights, while getting your insights and making predictions? In other words, does Arogyasetu Insights, that Itihas app, does it use the COVID app data?
No, we are not using the COVID app data. As of now, we are not using the COVID app data. Yes. COVID app data is a different thing. So we are not brought in vaccinations as a part of this.
Yeah. Also, it's important to keep that separation to gain trust. So,
trust, yes.
Yeah. So Joy says that this is a wonderful talk. First time that he's hearing this, he thanks you very much, Professor Kamakoti. Sure, then Saumyadeep Datta also says thanks for the wonderful talk, but he has a question as well. Did the heterogeneity of the mobile devices used pose any challenge for the deployment of our?
Yeah, lots.
And here I have another additional question. Did Arogyasetu, I mean, can we have a lesser version of Arogyasetu for perhaps non-smartphone setup?
So two things. Yes, the compatibility is the biggest thing. So we talk of standards, right? But when it comes to implementation, except for IEEE 754 floating point, nothing else is a standard. It's all device specific. Okay, so that much we can tell. I can confidently tell. Number one. Number two is that we also did it on this Reliance phone, right? This is high voice that also we tried, and it was so that was not a reduced version. Almost same functionality. No, same functionality, but it was done on a feature phone.
The interfaces were perhaps different.
Perhaps the Kai OS we had to rewrite the thing. Arogyasetu was rewritten for that.
Okay, I see. Now, perhaps the last question. So you mentioned that Itihas, for example, has a telco information coming into the picture, but in your talk, you didn't indicate how the telco information got integrated. Is there something that you can say?
So the telco information is basically, we have a set of all these positive tested patients, right? So if this positive tested patients, whichever mobile tower they have been associated in last 15 days, that was provided to us by NDMA. So the only which tower they were associated, for how much time they were associated. So that can be added to the lat long information of the self-assessment. And that can be used as an integrated thing for scoring. That was the.
And is there any plan to keep the Arogyasetu going in order to build this trust during the non-pandemic time?
So that's why COVID was integrated with this. So Arogyasetu will go upon, right? So with COVID, it will go next step, and then next, right? So slowly it can become a health app for our country, right? So
is there a plan in that direction? Are you already thinking about
all the effort that we have put? It will be in the best interest. Like now, 19.1 crore users are there. Best in our interest to see that this develops into a good health app at a later stage, right? And COVID. Integration with COVID was one very good thing. Now we can use the Arogyasetu to fix appointments, to download your vaccination stuff, etc.
Thank you very much, Professor Kamakoti. I think it was a phenomenal effort to get all of this in 21 days. Kudos to the team that brought this up. And I think 19.1 crore users is no mean achievement. It's larger than most countries' populations. Fantastic. And thank you very much for the very insightful talk. It was a pleasure to listen to you and learn about this, and looking forward to seeing Arogyasetu become the app of choice, health app for all of us. Yeah, thank you very much.
Thank you. Thank you very much.
Over to CNI Soumya to say a few final words about CNI.
Thank you, Professor Kamakoti, for the engaging talk, and thank you, Professor Rajesh. As discussed before, we would like to remind the audience to subscribe to our Google Groups, which is the mailing list for information on future talks. You can also visit our website for more details, and the links have already been pasted in the chat box. The link to the recorded video will be posted on our webpage. Thank you and have a great day.